Good day, learners. I am Mr. Teku, Subject Advisor for Natural Sciences from grade 4, 5, 6, up to grade 7. Today, I'm going to present to you energy insulation. But before I can start with energy insulation, I just want us to go back and look upon certain things that are very much important regarding energy. Right. The first one, I'm sure you still remember that when we define energy, we are saying that energy is the ability to do work. In other words, there is no work that can be done in the absence of energy. Hence, I am saying that energy is the ability to do work. The second thing is the law of conservation of energy. That law states that no one can create or nor destroy energy. No one can create or destroy energy. Remember that it's very much important to know that the total amount of energy that we are having on Earth, it comes from the sun. The total amount of energy that we are having on Earth, it comes from the sun. Point number 3. It is very much important to know that energy is very much expensive. So it is important to save it. Energy is very much expensive, and it is important to try by all means to save it. This simply says to us, there is no way we can separate energy insulation or insulation from conduction, convection, and radiation. There is no way we can separate that from conduction, convection, and radiation. In other words, we'll have to make a brief summary of the three. Right, let's see. Insulation and energy saving. As I said, we are going to deal with insulation and how energy can be saved. Right. When we are saying that we are having insulating materials, it simply means that insulation materials are materials that slow down. Very much important. Insulating materials are materials that are made in such a way that they slow down the transfer, either heat loss or gain through conduction, convection, and radiation. Remember I said there is no way you can separate these. In other words, insulation materials are materials that slow down or prevent either heat loss or gain through conduction. The second one, convection. The last one, radiation. Bear that in mind. What is heat transfer? Heat transfer is the movement of heat energy. The movement of heat energy from one substance to another, from one object to the other. I'm saying heat transfer is the movement of heat energy, very much important, heat energy from one substance to the other substance, or one object to another object. Let us look how. Let us look how heat energy always moves from a warmer substance to a cooler substance. Please take care of this. Always, heat energy will travel from a hotter substance to a cooler substance, or it will always move from a hot environment to a cooler environment, from where it is high to where it is low. Let me repeat myself again. I'm saying heat energy, it will always move from a warmer substance to a cooler substance. Warmer environment to a cooler environment. From where the temperature is high to where the temperature is low. From hot to cold. The greater the difference in temperature, as I said, the greater the difference in temperature between the substances, the faster the heat will transfer. In other words, where the temperature is very high, the faster the heat energy will be transferred to the cooler substances. Or the higher the temperature in a certain environment, the quicker the energy will be transferred or will be moved to the cooler environment. This one also is very much important. Remember, we said that in other words, it will move from where it is high to where it is low. In other words, energy is not balanced here until it is transferred. Let us see. Heat will continue to move until both substances are at the same temperature. In other words, if it moves from where it is high, it will be transferred in such a way that it goes to where it is cool. In science, where we are saying that until equilibrium is maintained. Until what is on the right is equal to what is on the left. What is on the left is equals to what is on the right. We are saying is going to be transferred in such a way that both substances are equal in temperature. And in science, we are saying that heat will always move from where it is high or at high temperature to where it is low until the equilibrium is maintained. Very much important. From hot, look at the picture in front of you, from hot, the red one, to the bluish one where it is cold until it is balanced or the equilibrium is maintained. Good. There are three types of heat transfer. As I said, you cannot separate it from insulation. There are three types of heat transfer. The first one, conduction. The second one, convection. The third one, radiation. I'm sure you are aware of it. Conduction, convection, and radiation. Right. Let us look at the video here.
Let's talk about heat transfer. What we're really talking about here is how energy moves, specifically heat energy, and how it gets from point A to point B, whether it be here on the surface of the Earth, up in the atmosphere, or even out in space. Heat transfer occurs really in three ways, and these include conduction, convection, and radiation. Let's take a look at each of these, starting with conduction. This is heat transfer as a result of molecular contact. The best way to understand conduction is by thinking about an example. So here I have a metallic spoon, and I imagine holding a match underneath it. Now what we know is that spoon is going to heat up, and not just the part of the spoon that's over the match, but rather the spoon as a whole. And the reason this happens is because of conduction. Energy from the flame is causing the molecules within the spoon to vibrate, and that's transferring energy from one to the next, to the next, to the next, until the entire spoon has warmed up. That heat has transferred throughout the entire material. Conduction is going to happen most effectively in solid materials. But let's not forget about convection and radiation. Let's look at convection. This is heat transfer through or as a result of density differences. Again, let's grab that match, and let's think about this for a minute. I think we all know it's probably not the best idea to hold your hand above an open flame like this, and that's because a lot of the heat energy generated by that flame is going to rise. That is purely because of the process of convection. You see, what's happening is the flame is causing the air to expand. And when it expands, it becomes less dense than the surrounding air and therefore floats upwards. And with it goes some of that heat energy. That's what convection is all about. And this is going to occur most effectively within liquids and gases. Finally, let's think about radiation. Radiation is heat transfer by wave motion. Let's pull that flame up one more time. I think we know that because of convection, heat is going to rise, but it's also going to travel outwards in the form of waves of energy, electromagnetic waves. And that's the third type of heat transfer. Radiation is really interesting in that it doesn't need a material for it to travel. So this can occur out in open, empty space. In fact, this is how energy travels from Earth's sun to the surface of the Earth. And so if we look back, we have our three types of heat transfer: conduction, convection, and radiation. And it's important to know the key word that goes with each one. For convection, it's going to be density differences. For conduction, it's going to be contact. And for radiation, it's going to be waves. We can sum all three types of heat transfer up in one diagram by looking at something as simple as a campfire. Imagine that you're camping and you hold a pot of water or stew above that flame. Well, right now in this one picture, we are seeing all three types of heat transfer take place. There's conduction happening as the flame is transferring energy directly to and throughout the pot as a result of molecular contact. Additionally, there's convection as heat from both the boiling pot and the flame itself is rising up as a result of density differences. And finally, there's radiation occurring all around the campfire as energy travels away from the flame in the form of electromagnetic waves. And that's a quick look at heat transfer.
Right. Let us look at conduction. Heat transfer by conduction is the heat transfer through direct contact. Through direct contact. If there is no direct contact, in other words, there is no way that conduction can take place. Molecules transfer energy to the molecules next to them. Look at the picture. Red molecule is attached to the blue one. That is the only way that heat can be transferred through conduction from one molecule to the other molecule. The molecules do not have to be of the same substance as indicated. The others can be of a solid, the others can be of a liquid. But as long as there is a contact between the two molecules, heat can be transferred. And we are saying it is transferred through what you call conduction. Right. Look at the picture. Warm water, cool water. There is a metal inserted between the two cups. The metal conducts heat, because it's a solid, from the cup of warm water to the cup of cool water. As I said, until the equilibrium is maintained through conduction. Through conduction. Right. Your Coke becomes cold because the heat from the soda transferred into the ice, not the other way around. Not vice versa. The heat from the soda transfers into the ice, not one way or the other. Radiation. Heat transfer by radiation is transfer of heat through electromagnetic waves. Through electromagnetic magnetic waves. Remember the statement I said that the total amount of energy that we are having, it comes from the sun. Now, let us look what is happening. There is no direct contact between the substances. Remember, I said in conduction, there is a direct contact. But when coming to radiation, there is no direct contact between the substances. Heat is transferred in the form of waves between the two substances from where it is hot to where it is cold until there is a balance between the two substances. Very much important. There is no direct contact between the substances, but heat is transferred between the two objects through what we call radiation. Look at the picture between the sun and our planet Earth. When you look at the two objects, there is an empty space between the two objects. And the sun, as I said, is the source of energy that we are having on Earth. In other words, heat from the sun radiates through empty space towards to the Earth. In other words, it moves through an empty space in contact with the particles of air, radiates to where? To our Mother Earth. Radiation, heat from the sun radiates through empty space to the Earth. The most important thing here is there is no direct contact between the two objects. That is the most important thing. There is no direct contact between the two objects. Remember, we are building this towards how can we save energy through insulation. That is the most important thing. I'm just giving you the background on how energy is transferred from one object to another. But it leads us to how energy can be saved through insulation. Convection. Heat transfer by convection is transfer of heat through the fluid, either liquid or gases, movement of currents. Very much important. Here, heat, it is transferred, we are saying through convection, either through the fluid. The fluid can be a liquid, or that fluid can be either water or drinks, and also it can be transferred through gases, oxygen, carbon dioxide, and the other gases, the movement of currents. Let us look at the picture in front of us. Warm fluids, always the same as warm air. Warm fluids will always rise, either in a pot or any container, when we are boiling water. Warm fluid will always rises up, cools down, sink, and then warmed again until the water in a pot or in a kettle boils. I'm repeating my statement. I'm saying always it can be either air or fluids. Once they are hot, they will always rise up, cool down. Once they cool down, they become heavy. They go down or they sink, and then are warm up again. That is the movement that we're seeing in the picture until it reaches the temperature of 100 degrees Celsius, then it starts to boil. Let us look at this one in front of us. As I said, warm air will always rise. From where? From a hot radiator. The air gets warm from the hot radiator. Once it gets hot, it becomes light. It rises up. Then there is an explanation from geography that says that the higher you go, the colder it becomes. In other words, that warm air once rises up, it loses heat. It can either attach to the cold window, it goes down, because cool air is always heavy. It moves back to the radiator, gain energy, rises up again, cools down, back to the radiator. The radiator warms the room by warming air around it. Then the warm air transfers heat to the rest of the room through convection. Remember, I said conduction, radiation, and convection. There is no way we can separate them from insulation. Let us look at this picture again. In a tight road, look at the middle where it is red. Warm air rises up, loses energy at the top, becomes cool and heavy. It goes down again to gain heat. As air above the rose warms up, it rises and is replaced by cool air, forming a convection current. Very much important. As air above road warms up, it rises and it is replaced by cool air, forming a convection current. Right. Also, let us look at this picture to sum up the three. Look at the arrows here. That's how radiation is taking place. That's how radiation is taking place. Convection. I said either in liquid or gas. Look at conduction. In other words, this picture illustrates all three types of heat transfer. Very much important question. Can you identify them all? Selena, are you able to identify where radiation is taking place, where convection is taking place, and where conduction is taking place? Introspection. As a learner, can you identify them all? Okay. Conductors. Sit down, relax. Now we are heading there towards insulation. Conductors. Let us look here.
Mercury are a few other examples of metals that conduct electric current. If you replace copper wires in our circuit with aluminium ones, then you will find that the bulb is still glowing. This proves that aluminium allows electric current to flow through it. In fact, this area of the bulb is itself made up of metal. Hence, if we connect the wire anywhere in this region, the bulb will still glow. It transfers the electricity to the terminal of the bulb and inside. We can actually test any object for conductivity. Break the circuit up from anywhere by cutting the copper wire. Now at this point, I want you to notice one thing. Look at this region. There is nothing present in this region that can transfer the electrical energy from one side to the other. But there is air in this region. So what can you infer from this? This tells us that air is an insulator. It does not conduct electricity. Bring any object that you want to test, say this iron nail. tie up both the ends of the wires at the two ends of iron and see if the bulb is glowing or not. If it glows, then it proves that the material that our object is made up of conducts electricity. Here the electric current is flowing through the iron nail. So our circuit is complete and the bulb glows. So this proves that iron is a conductor of electricity. Did you know that the human body is also a conductor of electricity? In fact, it's a very good conductor. This is the reason why we get an electric shock if we're not careful. The electric current flows through our body towards the earth. Now, which are the materials that do not conduct electricity? Materials such as plastic, rubber, cotton and wood do not conduct electricity. So they are insulators. For instance, instead of an iron nail, if we connect a plastic straw between the circuit, then the bulb will not glow.
Right.
But how exactly?
Very much important. We got materials that can conduct electricity. Listen to me very carefully. We got materials that can conduct electricity, such as copper, such as iron nails can conduct electricity. But the most important thing is that I need you to know. There are materials that we are saying are the bad conductors of electricity. In other words, such materials, electricity cannot move through them. And such materials, we call them insulators. In other words, these materials are very much important to can save energy loss. They can be used in such a way that they can prevent energy loss. Remember, I said to you, energy is very much important and we need to save it. So there are other materials that are very much important in our lives that are used to prevent energy loss. We call them the insulators. Air is a good insulator. Plastic, there is no way electricity can go through a plastic. A rubber, there is no way electricity can go through a rubber. Wood, there is no way electricity can go through wood. So many of them that we can mention, we call such materials insulators. That is why so many places, including the houses, they are roofed or they are built in such a way that their roofs are having insulators to prevent energy loss. When you are at home during your spare time, take a look at your geyser at home. You will find that it is covered with a shiny material or a blanket in order to prevent energy loss. Because once the water is hot and that geyser is not covered, in other words, we are going to lose energy from that geyser. So it's very much important for that geyser to be insulated by covering it with the material that will prevent energy loss. For an example, the clothes that you are wearing, that we are wearing also, are very much important because they help the body from losing heat energy. More especially, we are wearing warmer clothes during winter time because they are insulators. So, insulating materials are very much important because they do what? They save energy. As I said, energy is very much important. Here are the examples of insulators. Glass, the first one. There is no way that electricity can go through glass. No ways. It's a good insulator. Plastic. There is no way electricity can go through plastic. Ceramic. You can use it in glasses or in tiles. There is no way electricity can go through a ceramic. A rubber, the bends, and the others. There is no way electricity can go through it. Wood, no ways. A fabric, no ways. Paper, no ways. A cork, no ways. Wool, also no ways. In other words, these materials can be used as insulators to prevent heat loss or to prevent energy loss. They are very much important materials who can save energy if they can be used properly so. Let me take you back quickly before I can say thank you. Right. As I'm taking you back, let me remind you of something that's very much important. The most important thing is that people are sitting with. Can a body of a human being conduct electricity? Can a body of a human being conduct electricity? The answer is very simple. Yes. A human body can conduct electricity. In other words, a human body is not an insulator. That is why it's important to wear clothes. Right. I said we are going to deal with insulation and energy saving. Insulation materials are materials that slow down or can prevent the heat loss or gain through conduction, convection, and radiation. We talked about heat transfer or movement from one substance to the other substance. A picture shows us how heat can move from hot to cold. The greater the difference in temperature between the two substances, the faster, very much important, the faster the heat will transfer. We also talked about we'll continue to move from one place to another, from where it is hot to where it is cold until equilibrium is maintained. 3 types of heat transfer: conduction, convection, and radiation. The videos
Let's
I
talk
played,
about heat.
you still remember that. Conduction, heat transfer through direct contact. Very much important. As I move on, and then radiation, empty space, through air from the sun to our Mother Earth. I said between empty spaces, there is no direct contact. That's the picture to illustrate that. Then convection, either in liquids and gases. That's the picture to illustrate that. Always hot or hotter liquids will always rises up, sink, gas warm again rises up until equilibrium is maintained, as I said. That's it. Hot air from the radiator goes up, cools down, goes back to the cooler, just like that, until the whole place is hot. On the road is the same thing. That question again. Can you identify them all? Where is radiation, convection, and conduction? The conductors, the most important thing. Insulation, insulating materials are very much important in our lives because they help us to prevent heat loss. Insulating materials, very much important to prevent the heat loss. I said, here are the examples of the insulators when we are dealing with insulation: glass, plastic, ceramic, rubber, wood, wool, fabric, cork, paper. Everything of the best. May God be with you until we meet again.